Decimals, dividing. Decimals, dividing, single digit. I have the problem written out left to right, top to bottom, and inside out, and on the whiteboard. This time we have decimals, so what do we do with that? Fun news, it just comes straight up. It's lined up just like we do with addition or subtraction. Now, we're dividing by 3, so keep in mind that 3 times table. 3 does not go into 0, so we can put a 0 over here. 3 doesn't go into 1, so we put a 0 here. 3 goes into 15 beautifully by multiplying by 5, and 3 times 5 is 15. We subtract, and we get a remainder of 0. Almost every math teacher will want you to keep showing work until you get this at the bottom. This is not required in anybody else's math class, but I do it because it really helps students to see how did we get this number here. Also, multiplying at a diagonal is often very difficult, so this has helped a lot of students. The decimal comes straight up. Unlike the previous problems, we have to put these zeros in here to hold the places because of that decimal. That's going to be important. Decimals, dividing, single digit. Again, left to right, top to bottom, inside out. But you'll notice that a change happened between the original problem and the inside out version. We can't have a decimal in the second position. We can't have a decimal on the bottom, and we can't have a decimal here on the outside. So in order to fix that, what we did was we moved the decimal over one place on the top and the bottom. You must do it on both, otherwise it's not fair. So what we did was we actually multiplied the top and the bottom of this fraction or division problem by 10. That moves the decimal over one to the right. We'll get into this more when we're talking about fractions. So now we can do inside out. And you'll notice that I left up the problem from the previous problem, but I moved the decimal over here. And all we have to do is move that decimal straight up. And now we only want 1 0 in the front of our decimal, and that's our new answer. Decimals, dividing. Single digit, dividing 0. You might remember this from whole number division, but 0 divided by 0.3, 0 divided by 0.3. We don't want this decimal here in the denominator or the bottom of the fraction, so we move it over one place. Moving a decimal over one place for 0 doesn't do anything, and we can write it inside out. Now, if you remember, 0 divided by 3 means I will have 0 dots, or 0 pluses or minuses, and I will divide it into 3 equal groups. The answer is the number inside of each group, which means that 0 divided by any number other than 0 is going to equal 0. Decimals, dividing. Single digit, dividing by 0. Dividing by 0 and dividing 0 are actually very different. A lot of students get confused on this. So I have it written left to right, top to bottom, and inside out. Anytime you have a 0 in the denominator or the bottom of a fraction, or you're dividing by 0, bad things are going to happen. So we're going to have 1.5. We're going to divide it by 0, and we're going to get undefined because you can't divide by 0. So the answer is just the word undefined. You just write that, and your teacher should take it. Decimals, dividing, single digit. We have the problem written left to right, top to bottom, and inside out. But you'll see that again, something happened between the original version of the problem and this one. We're not allowed to have a decimal in the bottom. So we move the decimal one to the right on the bottom, and to be fair, we move it one to the right on the top, which gives us this lovely problem. As always, keep in mind your 3 times tables. 3 goes into 5 one time, and 3 times 1 is 3. Subtracting gives us 2, bring down the 7. 3 goes into 27 beautifully 9 times, And 3 times 9 is 27. Subtracting. We get a 0 and bring down the 6. 3 times what gives us 6? We have 2. We think about 3 times 2 gives us 6. Subtract that. And we have a remainder of 0. So 57.6 divided by 0.3 is the same as 576 divided by 3, which is 192. Decimals dividing single digit. This looks an awful lot like the last problem, which I have written left to right, top to bottom, and inside out. But this time there are different decimal places. So if you look, we again move the decimal over once on the top and once on the bottom to be fair, but that leaves a decimal right here. The only difference between the last problem and this problem is that you take the decimal and move it straight up. Now, instead of 192, the answer is 1.92. Decimals dividing multiple digit with a terminating decimal. It doesn't look like there are decimals here, but there will be. So, as usual, it has been written left to right, top to bottom, and inside out. And again on the whiteboard. We're dividing by 5s, so keep in mind your 5 times table. Starting from the left, heading towards the right, 5 goes into 7. Close as you can without going over, that is 5 times 1. So think about 5 times 1 is 5. And we subtract. Bing! 2, bring down the 8. If it makes you happy to draw a little arrow, you can draw a little arrow. 5 into 28, close as you can get without going over, that is 5. 5 times 5 is 25, and we subtract. And you get 3, and bring down the 2. And 5 into 32, close as you can get without going over, looks like 30. That is a 6 here, and so 5 times 6 is 30. And we subtract. And we get a 2. Now, in the past, we said, hey, we could just put the R with a 2. We could make it into a mixed number and have 156 and the fraction 2 over 5. But wait, there's more. We're going to use decimals. So, we're going to put a decimal and a 0. Remember that if you have a decimal here, it has to come straight up and go there as well. Now, this 0 will also come down here. Oh my gosh, look at all these things that are happening. 5 into 20, close as you can without going over, is 4. I'm going to extend this vinculum here, which is this bar. And 5 times 4 is 20. And we subtract. And you keep going until you get a remainder of 0. This is called a terminating decimal, meaning that you can divide and divide until it actually stops at the end. Decimals dividing multiple digit. We have left to right, top to bottom, and inside out, and on the whiteboard. Again, because you cannot have decimals in the bottom, you have to move it over, in this case 2 places on the bottom, and to be fair, 2 places on the top, before you can write it like this. This is our 21 times table, so keep that 21 times table in mind. 21 is too big to go into 1. 21 is too big to go into 15. But 21 can go into 155, going from the bottom, coming up. It's like 7 times. And 21 times 7 is 147. And we subtract. Okay, we need to do some borrowing here. And we will get 8, bring down the 4. 21 into 84, close as you can without going over. Hey, it goes exactly. And 21 times 4 is 84. And we subtract. We have a remainder of 0. Did you catch what I forgot to do? This is a decimal problem. There's a decimal here, and it has to come straight up into our answer. Now, let's let's do some estimation here. 7 20s is about 140, so a little over 7 and a little over 20 is about 155. So you can make sure that you can get really close to the answer using estimation. Decimals, dividing. Multiple digit with a repeating decimal. We're going to have it written left to right, top to bottom, inside out, and on the whiteboard. We're dividing by 3, so keep that 3 times table in mind. I feel like we've done this problem before. 3 into 7 goes in there twice, and 3 times 2 is 6, and we subtract. 7 minus 6 is 1, bring down the 8. 3 into 18 goes in there 6 times, and 3 times 6 is 18, and we subtract and get a 0. This 2 comes down. 3 goes into 2 0 times, and we get 3 times 0 is 0, and we subtract, and we get 2 still. All right. But we want to make a decimal. It doesn't look like there's a decimal, but we're going to make a decimal. We're going to have to keep going here, and this decimal will come straight up, and this 0 will come straight down. Now, we want to look at 3 into 20, and that's going to get close as we can without going over. We're going to have a 6, and we have 3 times 6 is 18, and we subtract. We get a 2 again. So we put another 0 here, and we bring it down. 3 goes into 26 times, and 3 times 6 is 18, and we subtract and get a 2. And we feel like we've seen this before. We may have seen it before a few times. So this is a repeating decimal. This 6 is going to keep repeating. And rather than continuing on for the rest of our lives, doing the same division, we can actually rewind back to the very first repeat and put a bar that says that this 6 will keep repeating over and over. Decimals, dividing. Single digit with a remainder. We have the problem written left to right, top to bottom, and inside out. As usual, if you have the decimal on the bottom, if you have the decimal in the second place, if you have a decimal on the outside, that's bad. So you'll notice that this time there are 2 decimal places. So if I need to move it over 2 places to the right on the bottom, I must be fair and move it 2 places to right on the top. That gives me 782 divided by 3, keeping in mind that 3 times table. 3 goes into 7. As close as you can without going over. That's 3 times 2 is 6. Subtracting. Bring down the 8. 3 into 18. We have 3 times 6 is beautifully 18. Subtracting. Bringing down the 2. 3 goes into 2. Close as you can without going over. 0 times, and 3 times 0 is 0. Subtracting, and we have 2. Now, in the past, we've been able to do an R2 for a remainder of 2, or a mixed number 260 and 2 over 3. However, I suspect that teachers teaching decimals are going to want you to continue. The decimal does not come down. All right. I put a decimal and a 0. I can put as many zeros as I have to. And we're going to keep going. 3 into 20. Going as close as we can without going over. It looks like 6. Remember that this decimal comes straight up. And we have 3 times 6 is 18. Subtracting, we get 2. Oh, so we put a 0, which brings down a 0. Hey, I feel like I've done this before, and I'm going to get a 3 times 6 is 18. And I will subtract it. And I will get a 2. Do you see that I can do this forever? This is called a repeating decimal. So instead of continuing to do 6s and 6s and 6s, what we would do is rewind a little bit and put a bar that says just the 6 repeats. Now, things will happen. We will occasionally have problems like this, where instead of having a 6 repeating, we'll have 2 numbers that repeat. So be careful about that. All right, here we go. Decimals, dividing. Multiple digit with a repeating decimal. We have left to right, top to bottom, and inside out, and on the whiteboard. We're dividing by 11, so keep that 11 times table handy. Now, I already told you this is going to be a repeating decimal, so instead of putting it in one by one, I'm going to put in a whole bunch of zeros here, because I know that I'm going to have a decimal answer, and I know that my decimal comes straight up. It should be lined up just like with addition and subtraction, but not with multiplication. Because 11 is too big to go into 3, it is appropriate to put a 0 in the front of your decimal. 11 into 30, we look close as you can get without going over. It goes in there twice. And we think about 11 times 2 is 22. We subtract. We also think about borrowing when we are subtracting. And we get 8. And bring down the 0. 11 into 80, close as we can without going over, is 7. And 11 times 7 is 77. And we subtract, which gives us some borrowing and 3. Bring down the 0. 11 into 30, you might feel like we've just done this, because we've just done this. It goes in there twice, and 11 times 2 is 22. And we can subtract and borrow. And we feel like we've done this before, and we can bring down the 0, and we say 11 into 80. It feels like we just did that. It goes in there 7 times. So instead of doing this over and over for the rest of our lives, we can actually rewind back to the first 27. As soon as we realize that we're going around in circles, and that we're going to get another 30, and we put a bar over this, meaning the 2, 7, and 2, 7, and 2, 7 will keep repeating forever. And we subtract. And we get 7. And we have another 0 up here. And we bring it down. And, oh, I made a mistake. Let us go back. We have to